Hello everyone, my name is Fikri Rizaldi. You can call me Fikri and I'm from Waste Treatment Engineering Class 5A. My number is 10190400016. In this opportunity, I would like to present about undergraduate thesis. The title is Design of Dissolved Air Flotation to Removal Fat Oil and Grease Levels in Wastewater of the Beer and Soft Drink Industry by Ahmad Randi Taufiqussyakir 10150400013. From the title, maybe you still don't know about DAF. What is DAF? Dissolved air flotation, or DEF, is a water treatment process that clarifies wastewater or other waters by the removal of suspended matter such as oil or solids. The removal is achieved by dissolving air in the water or wastewater under pressure and then releasing the air at atmospheric pressure in a flotation tank basin. The released air forms tiny bubbles which adhere to the suspended matter, causing the suspended matter to float to the surface of the water, where it may then be removed by a skimming device. Industrial waste is regulated in the IPLC, or Wastewater Disposal Permit. One of the parameters found in IPLC is fat, oil and grease. The condition of wastewater from the effluent, the fat and oil and grease content was obtained at 20 mg per liters. This study tried to apply DAF, or dissolved air flotation technology, as a pre-treatment by means of an air flotation system as a solution to these problems. The calculation results obtained for the saturation tank dimension, contact zone, separation zone, sedimentation zone. The DAF prototype test result at 4 bar pressure after the addition of a nozzle can reduce the concentration of oil and fat pollutant load from 254.7 mg per liter to 1.6 mg with an efficiency of 99.5% and has met the IPLC quality standard for beer and soft drink industry, that is 1.790 mg per liters. Beer and soft drink industry in producing a product will produce a waste, especially wastewater. The level of industrial waste discharge is regulated in the IPLC, or Wastewater Disposal Permit, which also refers to the East Java Governor Regulation number 72 of 2030 concerning the quality standard of wastewater for industry and or other business activities, so that liquid waste must be processed to meet the quality standard set in the IPLC. Industrial waste is regulated in the IPLC, or Wastewater Disposal Permit. One of the parameters found in IPLC is fat, oil and grease. The condition of wastewater from the effluent, the fat, oil and grease content is obtained at 20 mg per liters. This study tried to apply DAF, or dissolved air flotation technology, as a pre-treatment by means of an air flotation system as a solution to these problems. The calculation results obtained for the saturation tank dimension, contact zone, separation zone, sedimentation zone. The DAF prototype test result at 4 bar pressure after the addition of a nozzle can reduce the concentration of oil and fat pollutant not from 254.7 mg per liter to 1.6 mg per liter with an efficiency of 99.4% and has met the IPLC quality standard for beer and soft drink industry, that is 1.79 mg per liters. Beer and soft drink industry in producing a product will produce waste, especially wastewater. The level of industrial waste discharge is regulated in the IPLC, or Wastewater Disposal Permit, which also refers to the East Java Governor Regulation number 72 of 2013 concerning the quality standard for wastewater of industry and or other business activities, so that wastewater must be processed to meet quality standard set in the IPLC. From the result of physical observation in the field and laboratory test data that the authors conducted at the laboratory of the beer and soft drink industry, Mojokerto district. The result obtained were oil and fat content of 20 mg per liter. The data from the wastewater test result, the content of oil and fat that is still dissolved in the effluent is still high and exceeds the quality standard of wastewater. Based on the problem and the result of the literature study, the study thesis to apply the dissolved air flotation system named DAF or dissolved air flotation. From the condition that underlying the research of this final project, several problems can be formulated. There are how the DAF design can reduce the oil and fat content to below the wastewater quality standard, and what is the effect of saturation pressure on the effectiveness of DAF. Limitation of the problem in this study are: first, experiments using a laboratory scale with a continuous system. Second, the research variable is pressure using variation of 2, 3, and 4 bar. Third, the quality standard for wastewater effluent refers to the IPLC of the beer and soft drink industry in Mojokerto district. And the last is experiment using wastewater from the beer and soft drink industry in Mojokerto district.
There are 8 processes of research carried out. First, research idea. The idea of this research arose because of the wastewater from the beer and soft drink industry in Mojokerto district, which has a high oil and fat content. Second, study of literature. This literature study was obtained from textbook source, research journal, article, internet, regulation, and final project. Third, data collection. The data are collected in the form of primary data and secondary data. Fourth, prototype design. The design begins with the creation of process flow scheme diagram, then make detailed engineering drawing for each component of the process, then calculation and drawings. 5. Preparation of tools and materials. The tools are cutting tools, elbows, pump meter with a capacity 2014 liter per hour, 115 liter drum, tractor, and pump. And the material are resin, catalyst, wax, plywood, PVC pipe, iron pipe, bolt, nuts, screamer, rotameter, bar metal, diffuser, scrap metal, and nozzle. From the calculation result of each unit, namely the saturation tank and flotation unit, which includes the contact zones, aeration zones, the sedimentation zone, it can be seen in the following table. In the table, it can be seen that the increase in operating pressure at saturation tanks will increase the efficiency of oil and grease removal. The increase in the efficiency of oil and fat produced is quite significant from a pressure of 2 bar to a pressure of 4 bar with an average value of above 40%. Based on the testing and research that has been done, it can be concluded that the dimensions for saturation tanks is long is 222 meters and diameters is 148.3 millimeters. Contact zones 100 millimeters, x 400 millimeters and 500 millimeters, and aeration zone 700 millimeters, x 400 millimeters and 700 millimeters. Sedimentation zones A1 is 400 millimeters, x 600 millimeters, and A2 is 200 millimeters, x 100 millimeters, and height is 300 millimeters. And the DEF prototype at a pressure of 4 bar after the addition of the nozzle was able to reduce the concentration of oil and fat pollutant loads from 254.7 mg per liter to 1.6 mg per liter with an efficiency of 99.4%. I think that's all. Thank you very much for your attention and see you